Trig equations. Cool, right, I like these questions. So to do these questions, it's a really good idea to start by writing down the identities that you need to know. Now, whilst it would be a good idea to learn those identities, I tend to like to make them up on the fly. So the one identity you definitely remember is sine squared plus cos squared equals 1. And to find the identities you need for this question, you have to divide by sine squared, all of these, everything, or alternatively divide by cos squared. And I'm going to do that in my head now and write the new identities on the left over here, okay? So sine squared divided by sine squared is 1, so I'm just doing that divided by that. Now I'm going to do cos squared divided by sine squared, which is cot squared. And now I'll do 1 divided by sine squared, which is cosec squared. So that is the first identity. The second identity is the same thing, but dividing by cos. And if you're still not sure what I'm doing this divided by this, then this divided by this, then this divided by this, okay? So it's all being divided by cos. Sine divided by cos is tan, so tan squared theta, plus cos squared divided by cos squared is 1. 1 divided by cos squared is sec squared theta. There you go. So which identity do you think we're going to use in this question? Look at the question. Look at the squared versions. We've got a tan and a sec. Well, we can turn sec into tan. So why not do that then? Okay, instead of turning, you could argue, why not turn tan into sec? Well, the reason why we wouldn't do that is because look at the middle. There's a tan theta. We haven't got an actual formula to turn tan into sec, just tan squared. So we are going to go sec squared equals tan squared plus 1. Here we go. I'm going to rewrite the question. So 2 tan squared theta plus 2 tan theta minus, and in brackets now, instead of sec squared theta, because sec squared theta is equal to this, I'm going to write that there. Like that. All of that's equal to 2. And it's just a case of rearranging now, so let's do it. We got 2 tan squared theta plus 2 tan theta. Right, let's expand this. So by expanding a minus bracket, we just do minus tan squared theta. And then a minus and a plus makes a minus. So minus 1. And that equals 2. This is turning into a quadratic equation. You can see it happening because we've got some tan squareds, we've got a tan, and we've got a constant. So let's get all the tan squareds together. So we've got 1 tan squared plus 2 tan theta. Now the constants, we'll bring the 2 over to make it equal to 0. Oh, excuse me. And that's going to be minus 3 equals 0. And that is our quadratic. I'm just going to double check I've not made a mistake. Have I made a mistake? Have I made a mistake? Nope, that's good. Okay, so next we're going to, normally you could like use your calculator or something to factorize this. So I'm just going to factorize into one bracket because it's quadratic like any other, like x squared plus 2x minus 3 equal 0. You could factorize that. That goes to x 3, 1 plus minus. Like that. So instead of x's, I'm just going to write tans. So this is, and I'll get rid of this as well. It is tan theta minus 1 tan theta plus 3. And if you expand that out, you will get the expression above, the equation above. Right, so that means that tan theta is equal to 1 and tan theta equals minus 3. And you will need to solve these between 0 and 360. Okay, you can use the tan graph if you like to do this. And we're going to need some asymptotes, 90 and 270. We'll check a one there, so 90, 180, 270, 360. The graph is going to look like this. Whoop, whoop, Whoop. There you go, that's the tan graph. And we've got tan equals 1. Well, tan equals 1 is likely to be here. Whoa, across there. It's a bit of a thick line there. So what I might do is drop that back. Do that again. There you go. And tan of minus 3 is further down, so more like down here. And let's take a look at where those solutions are. We've got one there, and we've got one there. We've got one here, and one here. And we find the first one by doing the inverse tan of 1, and the inverse tan of minus 3 is the second one. Okay, so let's put that in our calculator. So shift tan 1 is going to be 45, correct? That's 45 degrees. So where the graph hits 0, so there, the distance to the right is 45. So the next one you need to add 180 onto that, because you can see we're just 180 distance away, or 180 plus this 45, that's 225. So there you go. With tan minus 1 and 3, excuse me. Tired. We get minus 71. Ooh, minus 71. Why do we get minus 71? Because if we bring this down, this would hit here. So the difference to the left and when the graph hits 0 is minus 71.57. Minus 71.57. I'll put that down. It's not an answer. But there you go. And you can just add 180. That's a cheat for tan. You can keep adding 180. Or you can do 180 degrees minus, because it's the same distance there, 71.57, which is, what's that, 108.43 degrees. And then you can do 360 minus the same, because it is the same distance. 288.43. Use your calculators. So the 4 answers in this question are 45, 225, 108, 288. And that's that question. Make sure you draw your tan graphs. Make sure you be careful with the factorizing, etc.